we have two case studies, as Mike said. The first one is going to be where two companies merged, and the director of sales from GlaxoSmithKline, this is when Glaxo Wellcome merged with SmithKline Beecham. This is years ago. So now they have to combine their sales forces, and this fella had just taken the Six Sigma DOE portion of the black belt training, and he says, well, I could apply this concept of evaluating these factors independently and looking for interaction effects to combining my sales forces. So that's exactly what he did. He wanted to do a simple, obviously there's more than 3 factors that affect sales. But what I'm showing you on the screen right now is an IPO diagram, standing for input, process, output. The output here is sales. Keep in mind that sales is measured in dollars, and more dollars is better. Bigger is better for the output. We just want to remember that, so that when we get into the graphs, we remember that bigger numbers are better. And then the factors he wanted to evaluate are product types. He took 2 of the top product types they had, and then, of course, the sales backgrounds are from each of the 2 different companies, and the customer types I'm not going to relate, but there's 2 different customer types. So the factors that he wanted to investigate were product type, sales background, and customer type. And he's got 2 levels for each of those. And he wanted to take a look at his sales force, and he had a lot of sales reps. So the beauty of the design I'm going to show you, which will turn out to be an 8-run full factorial design, because you have 2 choices for product type, 2 choices for sales background, 2 choices for customer type. So the design I'm going to show you or generate for you, or allow the software to generate for us, is going to end up being a full factorial design, which will allow us to evaluate all of the interaction effects amongst those 3, as well as the main effects. Now, the beauty of this, he could have gotten this data, Mike, from just historical data. But the point I want to make is that he randomized his sales reps to each of the 8 combinations that I'm going to show you. So he had 16 sales reps for each of the combinations that I'm going to show you. So he's replicating the design 16 times. So he's getting data from 16 different sales reps for each of the 8 combinations. So let's go into the software right now, and let me just show you from scratch. I'm going to be using, let me use the sales data and sheet 1 here. I'm going to start from scratch to demonstrate this program that I call DOE Pro. DOE Pro is a very KISS approach to DOE. It allows a practitioner to come in and create a design like using computer aided. We use let the computer select the design for us. The software will ask us, how many levels do you want to test at? Well, the simplest is 2 levels. You got to test at least 2 levels. 3-level designs we won't get into today, but 2 levels. But we have 3 factors. There were 3 inputs on that IPO diagram. They were product type, they were sales background, and then customer type. So we just press next, and then it comes up if you want to let the software, you want to put in the real life factors, so you can say, oh, factor A is not A, but it's product type. So you type that in. You come over and give it the 2 levels, the low and the high setting, and then you go to factor B, which is sales. I could just put background in there because background starts with the letter B, but we'll just say sales background just to remember what it is. We have 2 levels there, and C is, guess what? C starts with customer. Customer starts with C. So customers factor C, and we have 2 different types of customers. And so all you have to do is enter the factor names, their lows and highs. Now, in this case, you know, if we had octane level, would be 85 or a 91. You would put 85 or 91 in there. For tire pressure, you might put 25 PSA and 35 for the high. So in this case, it's pretty categorical. These factors here are categorical factors, product type. They are qualitative. They are not quantitative types of factors.
Understand. So, Mark, I believe you want the low on customer type to be a 1.
Thank you very much.
You bet.
Okay, good. So we press next, and then it asks how many responses. DOE Pro will handle multiple responses. We only have 1 response here. It's sales, and he has 16 reps. Actually, these are sales reps, and guess what? Sales reps means replications in this case. So reps is really replication. So we put this in response. We only have 1 response, and we're going to call that sales. This is measured in dollars, of course. And here is your setup. So the software comes back and says, those are your 8 combinations you want to test. This is your design matrix right here. It tells you that test case number 1 or row number or run number 1 is product type 1 with sales background 1 with customer type 1. And then, of course, you have 16 different reps. So we're going to have 16 responses. Let me just go, and I'm not going to take the time to put the data in because I've got this already set up. So let me go to the sales data analysis here. Now I've got the data in. Those are in thousands of dollars. So when you see a 25 right in here, that's to the nearest thousandths of dollar there. So each of the Ys, Y1, Y2, represents a sales representative, which represents actually in this designed experiment a replication. So we're getting data from 16 different reps, each of the combinations here, okay? So that's a very simple, actually this 8-run design for 3 factors, each at 2 levels, Mike, is probably the most common design done out there in DOE today because you don't have a lot of test cases. You have 8 test cases. You can evaluate up to 3 factors in this guy, each at 2 levels, and you'll get all the interactions free of charge, clean, no confounding, no aliasing, completely independent evaluation. So that's what we have here. So to do the analysis here, there's a couple of things we can do. We can go right to regression analysis, and that's what we're going to do here. That is one way to analyze the data. It's the most typical way. And see, the software does the crunching here. The beauty of getting the regression analysis, say, Mark, where are you looking on this complex output?
Yeah.
I'm looking is right here. And if I see red, that means that's a significant factor or a significant interaction. Red in this case means your p-value or the probability of false detection is very, very small, less than 0.05. In the cases here, they're all 0.0000. 1 minus that p-value is your level of confidence. So I can be at least 99.99% confident that product type, because I'm looking at this guy, don't worry about the red up here for the constant. That's always going to be red. Okay. But it's these guys right in here that are significant or not significant. Product type is sales background by itself is not significant. Customer type by itself is not significant as given by the non-red values of the p-value. This guy is significant. AB, that is the interaction of product type and sales background, is significant. The AC interaction is not significant, but the BC, and believe it or not, there's a 3-way interaction, which we rarely see in electromechanical, in people types of processes, we will see more higher order interactions. And we're seeing that here on this sales process, an ABC interaction. So you can look at it this way. There's other diagnostics I could go into. One is this R-squared. R-squared just tells you of all the variation in those 16 times 8, what is that, 128 data points we saw back here on the design sheet. Of all of this data right in here, 90% of it is explained by these factors and interactions. That's what it's saying. So that's pretty good. I mean, we've used 3 factors to home in on, or I should say, and their interactions to home in on what's important and what's not. So we've got some important interaction effects here, Mike. And another way to look at this is Pareto effects. The Pareto diagram is always a nice guy to get. Let's get it for both Y and S. Y means the average, Y hat means average, and S hat means standard deviation. We do not see anything significant here affecting the standard deviation, which is represented by S. Those coefficients in the S model were not significant, but if you look at the Y ones, there are. If you look at those 4, those were the 4. Those 4 bars represent or correspond to the 4 factors or interaction effects that had significant or red p-values. P-values less than 0.05. And so product type, that's your biggest. See, the beauty of the Pareto, Mike, it tells you the relative importance of these factors and interactions, as well as the color coding brings back, is it statistically significant? So the Pareto itself gives you a relative indication of the importance of these factors and interactions. And the color coding tells you then, what's statistically significant and what is not. So, folks, do you have to be a mathematical wizard to figure out what's important here and what's not? I don't think so. The click of a button gave me this. The key thing is figuring out what are the factors and the effects. So this is very powerful stuff. Now, what we want to do is we want to get rid of, before we optimize or look at interaction effects, we want to get rid of the garbage in this model. This guy is garbage, AC. AC is not important. We're going to take it out of the model, all right? Why? Because its p-value is big. It's not significant. Now you say, Mark, are you going to take out C and B as well? The answer is no, and here is why. We have a little law called the law of hierarchy. I call that the parental law, that says if an interaction like AB is important, you will keep the main effects A and B in the model, okay? We could go into why that's important. You have a BC interaction here. You have an ABC interaction. So we're keeping A, B, and C, the parents of those interactions, whether they themselves or by themselves are significant or not. So this is going to be our best model here. We saw nothing significant over in the S hat model. This S hat over here, so we're taking all this stuff out. It probably wouldn't make any difference if we took it out or left it in, to be perfectly honest, because nothing's significant there anyway. So, and then you re-regress, and you get what we call, as George Box would say, the most parsimonious model. By parsimonious, we mean the simplest model that we can get. So this Y hat model predicts the center of our distribution of the performance, which is sales, and S hat represents the standard deviation, which is pretty constant at about 5. That's in thousands of dollars, so that's about $5,000 standard deviation. But bottom line is, we've got a good model. Now, let's look at the interaction plots. There's an analysis tool here called multiple plots that will get you all of the different interactions, okay, are on this sheet, okay? And where you see intersecting lines, that's where you have an interaction, okay? Just to make the interpretation of this a little simpler. The interaction effects between product type and sales background, this guy right here, these are your main effects right down here. The main diagonal of this tells you, look, at product type was important. It's got a steep slope. Where the slopes are the steepest, that's where your most important effects are coming from. So let's home in on this guy. This is the AB interaction, this guy right here. Let's make this a lot bigger and then bring it down here so we can see it better. So we're looking at, right now, the AB interaction. There we go. Now I'm going to blow this guy up, make it a little bigger so you can see it. There, that's a little bigger. Yep. And this is called an interaction plot between product type, which is on the horizontal axis, and sales background, which is the color-coded line. So you have two lines, a black line and a blue line. Black is for sales background 1, blue is for sales background 2. Now, what is this intersecting line? What is this guy telling us? It's telling us, if we look at product 1, what is this best sales background to use? Well, remember, bigger is better. The blue option over the black is better. That's sales background 2. For product 1 is your best choice. Sales background, that's sales background 1 right there. That's a better choice than sales background 2 for product 2. So here you've got what is called an interaction plot, where the effect of one factor, namely product, is influenced by the level of another factor, in this case, sales background. So sales background 1 is the better choice for product 2 right there. And the bigger of the 2 points on the product 1 is sales background 2. So it's information like this, Mike, that allows the practitioner, in this case the director of sales, to say, hey, we've got maybe an educational issue here on training. These different sales backgrounds are coming in from 2 different companies, and maybe we've got to train. But for right now, we're getting the best bang for the buck, basically, by assigning sales background 2 to product 1 and sales background 1 to product 2.
So in a real-world example, Mark, sales background 2 might have been, they started off as a technical sales rep and they knew all the background of the pharmaceuticals before they became a sales rep. And so that allows them to sell product 1, which is a very technical drug or pharmaceutical stint, let's say, to doctors, whereas those salespeople that didn't come from a technical background wouldn't be able to sell those as well.
Precisely. That's the whole thing. It gives you information and knowledge now of what the potential causes of your increased or decreased sales are really, where are they really coming from.
Right.
And this is the nature of an interaction effect. These are critical. And with one factor at a time testing, A/B testing, Mike, you aren't going to get this kind of information. Guaranteed.
So what would the sales manager or director of sales do with this interaction chart, Mark? Might they say, okay, now I realize that there's an interaction and different salespeople are able to sell more effectively, so I need to split my products up into two different sales forces rather than every salesperson selling all of the drugs? I need to tackle it differently?
Exactly. That may be a partitioning of your sales force to say, for product 2, we're only going to have sales background sell that guy. For product 1, we're only going to have sales background 2 sell that guy. That's exactly right.
Okay.
It allows you to partition, develop a strategy or a policy that will allow you to maximize your revenue. That's the whole idea here.
Okay, that makes sense. So back on the marginal means of product type where we have a very steep slope over there, Mark, and it says Series 1 on the left. It's the upper left-hand graph. That's just a single factor. It says that...
Just the marginal means of product type. And that, because now notice, Mike, that this guy's pretty steep, right?
Right.
And this guy right here for sales background, not steep. It's pretty flat. That means the factors themselves are not significant. And you go back to the regression table, there's your product type that was significant, but B and C by themselves, sales background and customer type, were not significant. Notice their coefficients are very small compared to product type. Product type had the biggest coefficient. And product type there is a negative slope, and that's it's a negative number, the coefficient, and that is reflected in the negative slope of that.
I understand now. I understand how those are insignificant as single factors, but then the interaction is now very significant, and that makes perfect sense in a real world and statistical. Let me ask you this, Mark. The R-squared is 90%. You can see it 0.9034. What if my expert team of sales managers didn't include the product type factor? They just forgot it and they included 5 other factors. What would the R-squared be? Might it be like 20% or 10%, and that would indicate to me that, like, hey, we're missing something here?
Well, let's take it out. Let's take it out and see what it would. When your R-squared goes down, the number of times you take some of this stuff out. Let's take these 2 guys out and re-regress and see what R-squared does here, Mike. And we can get that pretty easily and just do the response. Look at R-squared's down to 16%. If you don't think product was a significant factor, think again, because now without it, you're down to 16%.
Okay, so when I'm doing a modeling like this, I want to make sure that I have at least, 90%, 80%? What's the number that assures me that I've got the right factors in my model?
Typically, in systems like this, like in sales, electromechanical systems, you want your R-squared to be up there over 0.7. Okay, that means you've got about 70% of your variability accounted for. In the psychological, if you're a psychiatrist and you're trying to measure or predict the performance of an individual or the behavior of an individual, if you can get an R-squared of 0.4, 0.5 and explain 40 to 50% of the variation in an individual's behavior, that's pretty doggone good.
Yeah.
So it depends on the application, but typically we like to look at 70% or higher. And if you don't have 90% like we have, it's an indication we haven't homed in on the right factors, exactly what you said. There are other factors out there that it can explain this variation that we are not able to explain right now.
Yeah. Mark, this seems pretty A to Z roadmappy. I understand it. I got my experts to tell me the factors. I defined the 2 different values and put it into the system. Your software told me what to go collect data on. It ran the numbers. I know what R-squared I look for. I can tell what the p-value is for the factors, what to eliminate, and then how to look at the interaction so that I can figure out how to change my business, how to set up my sales force so they're more effective. And then I can measure the revenue coming out after doing what my model said to do. The only question I have is around data collection. In this particular example, where we ran the different 16 replications, do I need to then go into Salesforce.com and quantify all the deals we just won and then bucketize them into product type, sales background, and customer type in order to gather this data? Do I sort of do it retroactively?
Mike, you can always add new data coming in from your new process to this data and upgrade your model. That's exactly what the folks at Boston Fleet Bank did in their HR. They continued. They didn't cut. They cut their turnover rate down from 50% down to about 15%, but they still had people occasionally leaving the company. They would still get that new data. They'd wrap that back in and use that to build a new model or an updated model. We do the same thing here. As we change our policies and we say, okay, if you got background 2, you guys are going to target product number 1, and sales background 1, you're going to target product number 2, like we saw in that interaction plot. And now you add that data to this data, the sales data. It becomes more of a historical data analysis. It's not a pure DOE, but you can still update your basic model that you used with the original data.
Okay. And these are likely manual processes, right?
Absolutely. Yeah.
Okay.
Yeah, pretty much manual. And, you'd want somebody who's familiar with the software to put the data in and update the model with the new data.
All right.
Fantastic example, Mark. I completely understand how this works, and I know how I would take the data and then analyze it and make changes to my business.